Good morning, everybody. Here is a video for the lesson on factoring the difference of two squares. There are other types of factoring out there that you'll learn in IM3, but this is the last variety that we teach in IM2. So I'm going to go over these 5 examples and give you some helpful hints and tricks just to make sure that your skill with factoring is rock solid and you know all that you need to know before you go to IM3. If you think about the trinomials that we factored into two binomials, this is very, very similar. And so you can expect 2 sets of parentheses like when we were factoring trinomials into 2 binomials. Students sometimes forget about this type of factoring, so you should always check for a greatest common factor first, and then check to see if maybe the difference of 2 squares is going to work. So let's just examine example 1. Is the number 4 a perfect square? Well, the answer is yes, because 2 times 2 gives you 4. And is x squared a perfect square? Yes, because x times x gives you x to the second. So notice that there's a minus sign in the middle. So what that means is this is going to factor exactly the same way every time. That's the cool thing about the difference of 2 squares is you don't really need that 2 by 2 box to complete it, although you can use that box if you want to. So let's just see how quick and easy this is to factor. The way it's going to factor is by 2 sets of parentheses. So I'm going to set up my 2 sets of parentheses. And here's the cool part. What times what gives you 4? Well, that answer is 2. So that tells me there's got to be a 2 here and a 2 here. That's pretty easy. Notice that the x squared term is negative. So what that means is one of these terms is going to have to be a plus, and one of these terms is going to have to be a minus. That has to be the case because notice that this last term is negative. So what goes here and here is just the square root of this term. And what is the square root of x to the second power? Well, the answer is x. And so if I put an x here and an x here, now my factorization is complete. Notice if you were to multiply these 2 things together, you get what we started with. So that means your factorization is correct. Notice that neither of these 2 terms can factor, so that means that our factorization is indeed done. Now look at how similar this one is. The terms are the same except the order has been switched. So I'm going to set up my 2 sets of parentheses just like I did in the example before. And maybe putting an equal sign here is a good idea. I kind of left that off in the last example. So here I know the 2 signs are going to have to be opposites. One's going to be a plus and one's going to be a minus, right? And notice that the square root of x squared is just x. So this time my x's need to come first. Notice that 4 is a perfect square. And so therefore my 2's are going to go here and here. So it might look as though the factorization here is the same as this, but they're actually not the same. The x plus 2 and x plus 2 are the same, but 2 minus x and x minus 2 are not the same. So the order in which you put these is kind of important. Okay. Some of the examples on your homework are simple like this, and some are a little bit trickier, kind of like the ones we'll do here. So let's try this one. 2 sets of parentheses. I'm going to put my equal sign there. And now notice that 100x to the 4th is a perfect square. So therefore, I can put 2 terms here that will work. And what I mean by that is the square root of this term is 10x to the second power. So I need a 10 times x to the second power here as well. Okay, now because of the minus sign, that means we have to have a plus and a minus as our signs in our binomial. Okay, now notice the y to the 6th is a perfect square too, and the reason is because the power is even. If this power isn't even, then it's not going to factor. Okay, it's not a perfect square. But here, what times what gives us y to the 6th? The answer to that is y to the 3rd. So I'm going to put my y to the 3rd here, and I'm going to put my y to the 3rd here. And notice y to the 3rd times y to the 3rd is y to the 6th. So if I was to multiply these two things together, I do get what's above it. Okay? Now, example 4. Here it's a little bit tricky because notice that the number 3 isn't a perfect square. Neither is the number 48. And so it looks like we have a problem that might not factor. But Mr. Ray's golden rule number 1 with factoring is to check for a greatest common factor first. Okay? And that's what we maybe would forget and perhaps skip. But let's not skip it. We're going to factor out the 3 because notice that both of these numbers are divisible by 3. So this is a little bit trickier example. And you do have quite a few of these on your homework. So we're going to pull out the 3 first. And if I pull out the 3 first, the way we did on our factoring about a week and a half ago, or maybe it's been 2 weeks given spring break, what goes inside? Let's see, there's going to have to be a minus sign in the middle. And that means there's an x to the 4th here. And if you divide 3 into 48, I think it goes in 16 times. And so here we have x to the 4th minus 16. Okay, so here's the cool thing, is this part right here is the difference of two squares, just like the examples we did above. So this is our first step in our factorization. I have to recopy the 3. It's part of the factorization. And now I need my 2 parentheses just like in the examples before. Okay? And now ask yourself, what times what gives me x to the 4th? Well, that's x to the 2nd. So I'm going to put x to the 2nd in the first position in both of my parentheses. Excuse me. Once again, since this is a negative sign, that means that one of these signs has to be a plus and the other one has to be a minus. Notice that 16 is a perfect square. What number times what number gives you 16? The answer is 4. So that means I need a 4 here and a 4 here. Okay, so it looks like we're done, but we're not. And here's why. Look at this binomial right here. Isn't it a perfect square and another perfect square with a minus sign in the middle? In fact, this x squared minus 4 is exactly what we factored up in this example. So this is an example of a problem that factors once, factors twice, and now even factors a 3rd time. So I'm going to copy the 3 down. It's part of our factorization. This doesn't factor because it's the sum of 2 squares. The sum of 2 squares in general doesn't factor. And so I'm going to just recopy the x squared plus 4 because that binomial is already prime. This example is the difference of 2 squares. And so I'm going to write 2 parentheses so we can factor it. And we already know what's factorization. We just did it up here. It was x plus 2 and x minus 2. And so now our factorization is complete. This one factored 3 times. Okay? All right, last example. Example 5. Notice we have a perfect square plus a perfect square. It's not a perfect square minus a perfect square. So these in general don't factor. But we can't skip Mr. Ray's golden rule number 1 when it comes to factoring. Don't this term and this term have a common factor? Of course they do. Because 25 goes into 25 once, and 25 goes into 400. Let's see, how many times does 25 go into 400? I think it's 16. trying to do that in my head. I'll double check that with a calculator. But in this example, 25 is a common factor, so it needs to get pulled out in front. And then inside we have the x squared plus 16. Okay, oop, forgot my equal sign. Okay, so I think we're done in this example because x squared plus 16 doesn't factor. Okay, I don't want to give you one last thing to remember. On your homework, I'll just put a star next to example 6. If I ever give you something like this, x squared plus 81 on your homework, it looks like it's factorable, but it's not because of the plus here instead of the minus. And so if I give you this on your homework, you should just say this example is prime. Prime refers to something that doesn't factor. You could also write not factorable. Factorable. I would like you to learn this term prime because it's important that you understand what that terminology actually gives us. Okay? This in a nutshell is what you're doing on your homework, and I think there's about 30 examples, okay? Some of them start pretty easy, and then many of them have common factors, kind of like I gave you in example 4. There's only 2 or 3 problems on your homework that are prime in this way, so always check for that greatest common factor first, and I wish you good luck and good thinking on your homework. So have a good day.